Welcome to Real Physics. This is my series about constants of nature, and today I'm talking about the speed of light c. Why talking about constants of nature at all? Because they are the royal road to understand fundamental physics, as I explained in this other video. So c, the speed of light, is maybe the most important constant of nature, and it is the first one to be observed. In 1676, the Danish astronomer Ole Rømer observed the orbiting period of the moons of Jupiter, and he noticed a very interesting anomaly. He said that at a certain time it seemed shorter, and at another time the orbital period seemed longer. And in fact, when the Earth was approaching Jupiter, then we had this seemingly shortening of the revolution time, and when the Earth was distancing itself, the period appeared longer. And from this very raw data, he was able to determine a pretty good approximation for the speed of light. Anyway, this remained astronomical curiosity for a long time, and later the French physicist Fizeau developed a very ingenious method to measure the speed of light on Earth. But yet it was not something considered really fundamental. Earlier, Newton had believed that the speed of light was indeed infinite, and c, so to speak, revealed its importance 200 years later when Einstein developed his special theory of relativity. And there it became apparent that there is a speed limit for masses. Masses, if they approach the speed of light, they become heavier, and this was something very sensational and indeed explained very elegantly by Einstein in his theory of relativity. However, the question remains why we do need this constant of nature at all. And despite all the elegance of Einstein's theory, he gave no real explanation. And also Hermann Minkowski, with his four-dimensional approach to space-time, completely glossed over this problem. And this is, I think, the reason why modern physics does not appreciate enough this fact, which is a real problem. You have to explain the very existence of the speed of light. It is an anomaly. There is a lot of confusion here because obviously meters and seconds are arbitrary definitions, and you can turn around things and use c to define meter, as it is done in modern times. So we have this constancy of the speed of light, 299792458 meters per second, and that's fixed. That's not a subject to measurement any longer. But this definition, in a way, it hides the fact that there is a problem and there is something interesting. There is this gentleman who says that c is a dimensionful quantity and we may set it to unity. That's okay, but the question remains whether this is a reasonable choice. I mean, you also can set, say, temperature to unity because it's a dimensionful quantity. The question is whether it's a reasonable choice to do meteorology, for example. And in this case, we have a very interesting theory of variable speed of light. It was Einstein's first idea in 1911 when he considered generalizing relativity. And as I have argued in another series of videos, it's a very interesting approach to general relativity. So there is a lot of confusion here. You can express c in any units, but it's not the number we have to explain. We have to explain the phenomenon, because the phenomenon of such a speed limit is still an anomaly. Why can masses not be accelerated beyond the local speed of electromagnetic waves? This is the fact to be explained. If you enjoyed the video, don't forget to like it, and if you're interested in fundamental physics, subscribe to this channel.